So I want to put up log rules and then do examples. So we're going to just talk about the natural log and see. I have the chat on the side if you have questions. Oops. Ln of A times B is equal to ln of A plus ln of B. Ln of A divided by B is ln of A and then subtract ln of B. And we use the power rule, so ln of A to a power R is R times ln of A. So let's do the derivative of a function, but first we're going to use log rules to rewrite the function expression. Okay. Y is equal to log base 5 of 3x plus 2 over x squared minus 1. This is all to power 7. So right now we're just going to use log rules and starting with bringing down 7. Let's go here. 7 log base 5 of 3x plus 2 divided by x squared subtract 1. Okay, and we're going to take that numerator, keep that same base, and subtract what's in the denominator. Everything's multiplied by 7. Cool. 7 multiplied by log base 5. 3x plus 2, and from here, subtract log base 5 of x squared minus 1. Is there anything else to do? I think we want to find the derivative. Okay. Oh, find y prime. So the derivative of y with respect to x. Sorry, position. Nope. And then we're going to take the derivative with y equal to this. So y prime is equal to. We've got a 7 sitting out front. We want to do this derivative and then do this second term, take that derivative, and I think that's it. Okay. So we talked about this last time. We want to do 1 over what's in the argument and then multiply by ln of 5. So it'd be like 1 over 3x plus 2 ln 5. Double check though. Let's see, previous notes. 1 over this, multiplied by that. Cool. Then subtract. 1 over the argument, x squared minus 1, multiplied by ln of 5. And that's the derivative. So 7 times this term minus that term. Okay, I'm just going to put down like what that rule is. So if you have log base a of x, and you do the derivative with respect to x, it's equal to 1 over x, 1 over x times ln of a. 1 over x ln. Okay. Awesome. We got through. Oh, wait, yeah. I think that there's a little missing. Oh no, it's okay though. At least we have pieces of it. The problem's still here. So we did this, but I forgot to use the chain rule. So up here we need to we'll be just on the side. Okay, so that was okay, but we want to multiply by the derivative that was inside the function or in the argument. So the derivative of 3x plus 2, which will give us 3. Okay. And the derivative of what was in the argument, which was x squared minus 1. So multiply this by 2x. All right, that's better. And anything else? Looks good to me. I did simplify the problem though, so let's do this. So we want to get a common denominator, which would be 3x plus 2 times ln of 5 times x squared minus 1. So this would be 3x plus 2 times ln of 5. And we need that, x squared minus 1. Okay, so 2x over x squared minus 1 times ln of 5, and we're going to multiply by 3x plus 2 over 3x plus 2. Okay, so 3x squared minus 3. We'll put everything over that common denominator. Done. common denominator. Okay, we are here. 7 times. We'll find the numerator soon, but this is 3x plus 2. ln of 5. X squared minus 1. So it was 3x squared minus 3. Minus 6x squared minus 4x. So I'm going to have a negative 3x squared minus 4x minus 3. Oh, wait. Hang on. I'm going to check this out. Oh, cool. We're doing some extra work. I think we're good to go. I just didn't do this part myself. All right, so it will be 7. Negative 6. I'm sorry. Negative 6x squared with that positive 3x squared leaves this. Negative 3x squared. Subtract 4x. Subtract 3. That denominator. Okay. That's good. And I think for the next problem, we're going to need a lot of scratch work. So just make sure this all worked out and then try something else. I think we're ready. So example number 2. We have I equal to, looks good enough. Okay, ln of, oh, actually it's a lot of stuff. So let's go here. Three to the x multiplied by cosine of x squared over x cubed times e to the 5x and then I also put a power 5. Take the derivative, so find y prime, which is the derivative of y with respect to x. And actually, we're going to just work with log rules first, and then we're going to do the derivative soon. So first, let's call it so this is just y that we're given. So the y we have, we can write as 5 times ln of argument 3x cosine x over x cubed e. I'm going to do this in steps. So 5 multiplied by ln of what's in the numerator, and then subtract ln of what's in that denominator. Over here. Okay, so ln of that numerator minus ln of the denominator, and that we talked about before. Then we're going to have this 3x multiplied with cosine of x be ln of 3x plus ln of cosine x. Okay, and then subtract, let's just split this as one piece. Okay, so subtracting this part, which we're going to write as ln of x cubed plus ln of e to the 5x. This, and we're subtracting both of those terms. So let's still working on the original expression. So y is equal to 5 this way times x ln of 3 plus ln of cosine of x. Okay. Subtract 3 ln of x. Also subtracting 5x. Okay, so now we're actually going to find the derivative. So we have a 5 sitting here. And we're going to just do the derivative like term by term. So this one, ln of 3 is a number. So some number times x. Take the derivative, which is a power rule, leaves ln of 3. All right. This looks like a chain rule. So the first part is the derivative of the outside function, which would be ln, 1 over what's sitting inside. Actually, I think that something get lost. I lost this squared. It was cosine of x squared. No. It's not a big deal though. So we haven't gone too far. So back in your notes, each time inside of cosine x was supposed to be squared. I think it won't have a huge effect though if we keep on working. Let me check. This is in the original problem. I broke it down. Broke that down. So it's okay. X ln of 3, ln of cosine of x squared, that and that. All right, let's do the derivative. 5 times c ln of 3. That's fine. Okay, now we're at this part. So 1 over cosine of x squared. And it's a chain rule. So take the derivative of, it's inside that function. Derivative of cosine will give you negative sine. And leave that x squared inside. Okay, and then the chain rule again. Take the derivative of what's inside of that. So multiply by 2x. Okay. Minus 3 times the derivative of ln of x, which is 1 over x. Last part. Minus 5. All right. Looks good to me. I think we can simplify this a little bit. So we're going to write y prime and just at least fix this middle term. So it's 5 times ln of 3. Negative tangent of x squared. Times 2x. Minus 3 over x, minus 5. And that would be my answer for that one. Let's check it out though. This looks good, looks good. Okay. Excuse me. Okay, so I have kind of like an intro and then some steps to follow. Or when you kind of have a function to a function, and it would help to use log rules. Logarithmic differentiation. So for something like some function f of x, to some other function, like with another function as a power. Okay. So for problems like this, the first step would be take the natural log of both sides, but you could just do a log of both sides. We're going to stick with the natural log. Okay, so both sides of the equation. Next, you would simplify using log rules. Simplify as much as possible. Log. Then we're going to find the derivative, but take the derivative implicitly. Okay, so from this part, for number 3, we're going to start with something like this. So we have a function, we've taken the natural log of that function, and it has something like this, ln and a y, and then we're finding the derivative. Derivative of y with respect to x. Okay, and it will be a function, so it's 1 over y times y prime. So isolate y prime by multiplying both sides of the equation by y. Okay, and then a note that use the original y, or at least make sure your answer is back to the variable that you started with. All right, I didn't write it down. I put replace y. I think it's spelled. Well, that's fine. Let me just write it however. All right, so I think I have a couple examples. And some time. Awesome. First example is y equal to x with the power of sine of x. find y prime. So first, I'm gonna write this down just how we have it. Y is x with the power of sine of x. Okay, let's take the natural log of both sides. That lets us bring that sine of x and multiply it with ln of x. Let's go this way. Okay. Ln of y is equal to sine x. Ln of x. I think now we'll take the derivative. So find y prime. Natural log both sides. And now we're going to find the derivative. We're going to need to use a product rule on this side, and then since y is a function, this has a chain rule on the other side. So chain rule gives us 1 over y times y prime equal to, let's call this one f and g, and it's f prime g plus g prime f. Okay, so it's like my scratch work on the side. Okay, so we want the derivative of sine is cosine times ln x plus derivative of ln of x is 1 over x. Multiply it with cosine of x. Okay, it looks a little messy, but we'll just rewrite this. Have y prime over y equal to cosine x ln x add cosine of x over x. Then multiply both sides by y. Let's do line. Okay, just rewrite all this. Cosine x over x. Okay, so this will leave y prime. And on this side, put back what y was equal to, which is x with the power of sine of x. And then multiply with everything else. So I've gotten the derivative of y, the derivative of y with respect to x. and it's all written back in that variable x. Okay, the next one is going to take some time. I feel like we can at least start the problem and we'll come back and finish it next time. Cool. So we're going to, let's see, get through part of this example. Okay, so y is equal to the square root of 2 with the power x, tangent x, over, oh, actually it's tangent of 5x. Crazy. Cool. This is over x cubed e to the 2x. Okay. So I think we're at least just rewrite y, and then next time we'll actually find the derivative. So we have y equal to everything here with 1/2 power. Okay, then let's see, take the natural log of both sides. Okay. So we're going to use this part and this part. ln of y equal to ln of everything here. I'm going to get the ink shaken up. All right, ln equal to, and let's do the power rule as like part of this step. So we'll have a 1/2 ln of this. X tangent of 5x over x cubed e to the 2x. Okay, so it's natural log on both sides, and I think we're going to keep on working with natural log rules right here. So I have ln of y equal to this, which is equal to 1/2 ln of what's in the numerator, and then subtract ln of what's in the denominator. More log rules. So we've got multiplication here and here. So we'll take this over here. 1/2 multiplied by ln of 2 to the x plus ln of tangent 5x. Okay, subtract. Ln of x cubed plus ln of e to the 2x. Okay, so a moment. So we have this equal to this 1/2 x times ln of 2. Plus ln of tangent of 5x. Subtract this part, 3 ln of x. And then subtract that term right there, which is minus 2x. Okay, and all that work was just rewriting ln of y. So let's see, we got ln of y equal to this. It looks good. And then I said we'll come back next time to find the derivative. All right, so that's good for now. Let's call this